Dzień dobry Państwu, nazywam się Piotr Maksyś, jestem dyrektorem klastra technologii wodorowych. Miło mi gościć Państwa w Gdańskim Parku Naukowo-Technologicznym. Wszystkich Państwa, którzy otrzymali zaproszenie, naszych drogich prelegentów i sponsorów. Witam także Państwa na naszych streamach, zarówno dziś, jak i jutro. Mam nadzieję, że ta czwarta konferencja już poświęcona technologiom wodorowym w tym roku w trybie hybrydowym, mam nadzieję, że w przyszłym roku uda nam się zrobić całkowicie wydarzenie, w którym spotkamy się osobiście.
Face-to-face mode next year. We will be celebrating the 5th hydrogen anniversary, hopefully in a completely different shape, but we're still working on it, trying to make a consecutive edition even more special. No event was possible, was it not, for the sponsors, for the companies that cooperate with us, particularly in such a difficult mode, that is the hybrid mode, in which a lot of organization and technological effort is required. But the key figures for you and for me, the figures that will moderate the entire conference are Mr. Marek Foltynowicz, whom I would like to invite here, and Mr. Tomasz Pelc, Nexus Consultants, a gentleman you can always rely on. I'm really proud that we've been working together for so long a time. They've been with us ever since the beginning of our conference series on hydrogen. So I'm leaving you in good hands of our wonderful moderators, and I wish you a pleasant stream reception and good relations to all the guests that have paid a visit in person. Thank you very much, and I invite you yet again to the 4th conference devoted to Polish hydrogen technologies. Thank you. Welcome, ladies and gentlemen. Welcome, Tomek. Welcome, ladies and gentlemen, to the 4th conference, as mentioned by Peter. Peter, thank you for all the nice words we've heard. Ladies and gentlemen, there is no decarbonization of industry, and there is no meeting the Fit for 55 requirements if hydrogen is not introduced on a large scale. That is why today we would like to discuss Polish technologies that will be conducive to these developments as well as to education. We're going to talk about all that awaits us, but as Piotr mentioned, the conference wouldn't be possible if it was not for our sponsors and partners. Let me enumerate them at this point. The strategic partner of the conference is Bank Ochrony Środowiska. The main sponsor is the Wystrach Customer Solutions and High Pressure. We would like to welcome the representatives of the company present in the room. The partners are the Gdańsk Science and Technology Park and the Pomeranian Special Economic Zone. Thank you very much for making the venue available, as well as the Eco Council Company. The main program-related sponsor is the producer of all sorts of fuels, in the future also clean hydrogen, the Lotos Group. So thank you all for supporting our conference. But we are not only going to talk about Polish experiences, because as we know, we are only entering the era of hydrogen in Poland. We are going to rely on the positive benchmarks set by Europe and elsewhere in the world. That is why we are playing host today to guests from abroad. We would like to clash our point of view with what is going on out there, what decisions are made. We are going to discuss within a few panels, and the discussions will take up the topics that might be easy, but might be complicated on the other hand side, decision-making wise. I think it is worth realizing one thing. Hydrogen, the epoch of hydrogen, is not avoidable. It's not something that we should struggle with, but we should start to learn how to live with. That is why we need to start using hydrogen-based solutions, be able to make the most of them, rather than waiting for the distance between Europe and the world and our country to get ever larger. Rather than that, we should try to reduce it. Ladies and gentlemen, we are opening the first session devoted to the technologies that are supposed to lead to decarbonization, mostly owing to the use of various technologies. Of course, not only this, one of the basic technologies that could be used here is the technology of capturing CO2. Such studies and such projects are already operational in Poland, are being tested in Poland. I would like to invite the first panel speaker today. We are connecting online with Mr. Janusz Zdeb, representing Taron Wytwarzanie, Taron Generation. Janusz Zdeb is the main engineer in the research and technology department, Taron Wytwarzanie, dealing with power engineering for over 20 years, one of the top engineers on this project. Janusz, the floor is yours.
Dzień dobry
Good afternoon, ladies and gentlemen. I hope you can see my presentation. It's all good. We can hear you. Welcome, ladies and gentlemen. Welcome to the conference. Thank you very much for the introductory remarks and for introducing me. I'm happy to be able to share a few words on the experiences of Tauron Group, especially Tauron Wytwarzanie, Tauron Generation, on the topics concerning CO2 capturing, as well as technologies that rely on CO2 that we've developed and that concern power to gas or methanization. The topic of my presentation is going to contain the CO2 methanization system for energy storage via the SNG production. To begin with, just a few words on Tauron Wytwarzanie. This is a company belonging to the group, located in the southern part of Poland, responsible for the generation of electric energy, mostly from coal, but we have RES biomass-reliant facilities that are already being commissioned, but also those that are under construction. So we use both coal-based technologies as well as RES, such as PV farms, among others. As far as our activity goes related to CO2 capturing, our activity started in 2008 in this respect, when the first regulations, first directive appeared concerning CCS. That is when we started our first analysis, and we got to resolving how this would impact power engineering. As we know, the major CO2 emission volume comes from power engineering, so it was clear that these regulations sooner or later would affect our business, the operation of our generation units. It resulted in the fact of us striking into cooperation with national scientific institutions, both in the country and abroad. And first, we turned to Polish institutes, which gave rise to the fact that the first pilot installations, pilot systems were created in the facilities. They were erected within the strategic program for power engineering that was announced by the National Center for Research and Development. The streams were 4. We participated in 2 out of the 4 streams. One was managed by the Politechnika Śląska, so Silesian University of Technology, the other one by the Częstochowa University of Technology and Professor Wojciech Nowak. Within those 2 streams, those 2 main tasks that were implemented as far as power engineering goes, as a Tauron, we took up activities concerning CO2 capturing. Owing to this, we were able to build and run studies on the fumes, boiler fumes in the power generation plants. We started with the first tests in small labs through to to small installations, a few cubic meters located in a laboratory room, which resulted further on in a further stage of building a pilot installation, several dozen cubic meters located in the Center of Pure Technologies, TW, and the experience that we collected throughout the tests and studies helped us to develop a modular container facility for capturing exhaustions, fumes from the working facilities, Łaziska, as well as in the Jaworzno power plant. In Jaworzno, we had a fluid bed boiler. The installation that we built contained mostly a technological container. We had the sulfurization unit there with additional sulfur removal. We had absorption and desorption columns here, the whole sets of exchangers, and washes in the container that was technological, then the supervision container in which the technological process was supervised, all the data were registered. But owing to the fact that the installation was modular and mobile, we also have a container here that we call the storage container, to which the dismantled columns would be put on use for transportation purposes. This installation makes it possible for the gas to flow at 200 cubic meters. We're talking about boiler fumes here. The height of the tallest column is 15 meters. Over 180 measuring points were installed. We started testing in 2013. The first studies were not really optimistic. When you look at literature data, as far as the use of energy for the regeneration, we started at 4.26 megajoules per kilogram of captured CO2, but we managed to get down to around 3 megajoules per kilogram of CO2 captured. As for the implementation, we've implemented over 30 research campaigns. Over 300 tests were carried out with different changing parameters that would optimize the process. And there is a result with over 2,000 hours of operation of this installation on those two locations mentioned, and the capturing of around 100,000 kilograms of CO2. Owing to this endeavor, we've managed to get to the heart of the process. We've learned what its advantages and downsides were. Definitely, our approach was a novel one, and owing to this, we've elaborated our own way of regenerating eminence, which resulted in a patent that was granted in 2018. As we know, the energy policy and the stress on development of areas that are pretty unstable on the system make it necessary to introduce drastic changes in the image of power engineering. As the former speakers, moderators said, we are shifting to the other dimension of power engineering, the one in which the dominating function will be played by hydrogen. With this experience about CO2 capturing and knowing that in such volumes CO2 cannot be accepted and stored, we've taken up steps that would make it possible to change CO2 into a product or for it to become a carrier of energy. And here, analyzing different technologies, observing global research trends, we moved towards power-to-gas technologies, so those concerning methanization. We believe that CO2 can be a very good carrier of green hydrogen, and it can be a certain part of the storage, as well as an element stabilizing the power system. This is also confirmed by other sources and publications. You can see any technology of energy storage has its place in this chain, depending on what functions it is supposed to deliver. It should find its way to the mix of the energy system, to the power system. We've moved towards the high-scale storage solutions and also long-term storage solutions. As I said, the power-to-gas technology, despite it being treated as a storage system, also responds to a few issues that the power engineering today is bothered with. This is related to the reduction of CO2, to the increasing number of unstable areas sources, so renewable energy sources, which in turn makes the power system, our power plants, work pretty dynamically in terms of the activities they perform within the energy system. Depending on how we develop this element, it can also constitute a protection measure when thinking about natural gas. So to sum it up, we have intermittent renewable energy, which can be turned into hydrogen. The CO2 source, that is the industry of power engineering, combined with hydrogen, gives us a synthetic natural gas, which can be located on the market today, so it can be given back to the grid, or it can be consumed by end consumers or in transportation. Looking at it this way, we've managed to obtain financing from the European Technological Institute, EIT, from the Polish section Knowledge Innovation Community. We constructed a consortium, an international one, in which Tauron Wytwarzanie was a leader, responsible for the construction and testing of the entire system with methanization. We have foreign partners, both the scientific ones and the industrial ones. We've got CEA, the major French research institute that studied the operations of the reactor on a small scale. We've got Atmostat, responsible for the production of the reactor, and also the Polish side. We've got AGH in Krakow, responsible for testing of the kinetics of reaction and the methanization process for various catalysts. ICHPW testing the whole system in the demonstration scale in real conditions industry. Rafaco in West Technology and Trading, simulating processes. And it was Exertion that modeled the processes. So we had 6 work packages within the project. These concern testing of the catalyst, construction of the reactor on the spot, integrating the reactor by means of tests, and also scale up to a larger scale. So we referred to the 8 megawatt scale. Janusz, 5 minutes. Just to remind you, the project was launched in 2015 and completed in 2019. We know what methanization is about. The most important element is the exothermal surplus of heat. The laboratory tests were carried out in France using such a small reactor. The installation, the system tested, contains the electrolysis set and also the CO2 capturing unit, where CO2 is compressed, purified, then it gets to the mixer, then the hydrogen from electrolyzer is preheated. We have a 2-stage set here. In the first stage, we have methanization, then condensation, cooling, heating. The other step of the reactor, and then depending on the parameters, the gas can be either given to the flour or it can be given to the compression station so that we can use it as CNG. The visual model of this system is what you can see now. The installation generated 4 and 5 cubic meters per hour. Main container is the technologic one. The electrolyzer one is the one where hydrogen is generated. And the third container here is the one concerning gas analytics, because with any technological process, it is necessary to measure gas. So we've got the AKP container plus the commercial station and a flour that was used for testing gas. That does not meet requirements. Well, it was a test. So we tested different parameters. Not always did the quality suffice to compress methane. That was a reality. So on the right-hand side, we've got the existing CO2 capturing unit, the CNG one, and a car specially designed to CNG filling up. A lot of problems we occurred. It was new to us. The entire system was moved to the container, to the technological container vicinity itself. As you can see, there was an online analysis of all the parameters so that the installation could be launched in the safest possible manner. The first gas with CO2 from power engineering was generated in July 2018. This is a video. I'm not sure whether I'll be able to play it to you. Janusz, I don't think we have time for it, so let's skip it then. The first results in 2018, you see 80% of efficiency as for the capturing. We tested most of all the impact of pressure and temperature on the process parameters, as well as the flexibility of the operation of those reactors, methanization reactors. We can see here the changes depending on temperature, depending on pressure. You can see particular efficiencies on the first stage and the second stage of the methanization reactor. We also compared, owing to the fact that this is a research installation, it was possible to apply synthetic gases. CO2 was synthetic from the tank, and also CO2 from the capturing installation that I showed you before. There are no differences, exactly the same parameters. The system, the installation worked exact same way. The basic parameters of the installation that you can see, it worked between 250 to 350 degrees with a flow from 4 to 220 cubic meters of gas. As for the test results, we were able to reach, in the majority of cases, once the process has been mastered, we got conversion efficiency of 25 and more. A minute to go, Janusz. Okay, what I drew attention to is the volume of heat from the methanization process makes it possible for us to cover the needs for absorption of CO2 in the installation. So we can say that energy-wise, we can get a balance. And this is a concept that was awarded with a patent earlier this year. As regards the upscaling part, we prepared a concept of installation equivalent to 8 megawatts that would make it possible for it to also use RES and working with the existing capturing system in the power plant. The installations make it possible for the gas, for natural gas, to be fed back to the grid, and also the products of this project can be used as transportation fuel in CNG-powered engines. These activities that concern CO2 SNG, we decided to optimize research for optimizing possibilities, and we struck a cooperation with the Warsaw University of Technology. The result of it is a project, analogous one to the one we have, but using fuel cells, but also ceramic electrolyzers. And the installation of CO2 capturing in the project is near to completion. We are substituting MCFC fuel cells, and we use the SOE electrolyzer. We certainly hope that this installation will be launched further this year. The first tests show that this is viable. Now, this is what it more or less looks like in terms of the Tennessee installation. This is this part, and whilst this part has CO2 SNG, it is combined with processed gases that we generate from the Tennessee installation. So we produce the mixture of CO2 and H2 in the proportion 1:4, so that we can deliver it to the methanization reactors. It is a test installation of rather low level, but as in terms of scale. But we believe that the fuel cells have their future, so it is certainly worthwhile having a close look on them, developing their uses. In the meantime, you saw a few pictures of the actual system, what it looks like. And what can I tell you to end on? Well, all the experiences that we've gained over those 10 years resulted in the fact that we prepared a project within the competition, IPCEI Hydrogen, the Ministry of Climate and Environment, was one of the parties that issued a positive opinion. So we are going to keep on developing those solutions, hopefully moving on to commercial scale, so that we can show the use of methane or hydrogen also in other branches of the economy, so that it can be used in an optimal manner and inscribe itself in the existing infrastructure with alternative uses. Thank you so much for me. I do apologize for not sticking to the time limit. Thank you very much. I think that we are fully convinced that the direction of CO2 capturing and using it, especially when paired with electrolysis, can be the future of power-to-gas technologies. We would like to move on now to another topic concerning energy generation with the use of RES. The topic will be connected with HEPKINE, and it will be presented by the initiator of the cluster of hydrogen technologies, the moderator and expert of Pomorskie hydrogen valleys and other valleys, the owner of Nexus Company, a consulting company specializing in advisory on all sorts of walks of life, but recently also actively participating in hydrogen agreements. Tomek, the floor is yours. Thank you very much. I would like you to show, to begin with, Nexus's presentation. I will tell you about BPRORAF in a moment. BPRORAF belongs to a set of companies working on this project. The Neptune project was based on 8 years of our experience from when we dealt with hydrogen-related issues, and this is a project whose aim is to develop hydrogen technologies here in the Pomorskie region. In the project, we involved companies that are members of Hydrogen Cluster. And I do apologize, but if you could start it with the Nexus Company presentation. Thank you very much. So we would like to show you that the cluster that is based on functioning, building internal relationships between the membership companies involves them into common projects. But it is not only cluster-based companies that were involved to the project. Not all of them have the necessary competences. Therefore, you also see the names of the companies that deal strictly with maritime industry, because this is what the project is about. Nexus Company is an advisory company. You might wonder why we even deal with such topics. But as I mentioned, for 8 years we've been dealing with the topics of hydrogen technologies, and on the basis of those experiences and implementing projects financed from the European Union, we came up with a concept of building a project entitled Neptune. I think that this reduces the time for my presentation, because that was my first slide. Another one is the one concerning the approach to implementing of the project itself. I think this is something that will make it clearer for you what the entire idea of the project is. Browsing through the European hydrogen strategy as well as the European offshore strategy, you can notice one thing. When we say offshore, we think hydrogen. When we think hydrogen, we say offshore. These are two interconnected tools that we will base the future on from the point of view of Europe, and I think also globally. Hydrogen will constitute a trigger to change all the elements of the puzzle, all the issues concerning the new look on power engineering and on the solutions used within it. As I have no slides, I will just tell you about it. Imagine, ladies and gentlemen, that in offshore installations, whether these are stations or other installations placed on the sea, we mount hydrogen systems as well, to use them first of all to suck in salt water, then to remove salt of it, demineralize it, then using the electrolysis to produce hydrogen. We compress it and we store it, and then we use it as fuel for the ships for bunkering. Oh, we are on the right path, as I've mentioned, ladies and gentlemen, already. Thank you. You can see here that Neptune has its own name. We have a nice logotype already. A special purpose vehicle was established for this project to be implemented. As I've briefly mentioned, while I described what it is about, so we produce hydrogen from salted water. First of all, we want to use it for the bunkering of ships that coal at offshore wind farms to service them every day. It is one of the 4 projects of this kind implemented globally now. I'm talking about them being implemented because our project is not only in the conceptual phase, as you'll learn in a moment. The main issue as regards the production of electric energy for the wind farms is that we cannot always give the electricity back to the national grids. These are fledgling diseases. Same was the case in UK, in the UK, Denmark, and so on. So they keep on searching for the solutions. What to do when the energy cannot be received by the land? How to balance the production of energy from offshore wind farms? And that is why we are thinking about producing hydrogen locally. As mentioned, the project constitutes a few components. It has elements that will make it possible to obtain salt water, desalinate it, demineralize it, then to divide it through the electrolysis. Hydrogen will be produced and compressed, stored, and then used for bunkering purposes. Vessels, obviously. The project, as mentioned at the very beginning of my contribution, involves companies that are actively operational in the hydrogen technologies cluster, but we also invited PCHET to it. The PCHET is a forerunner in terms of gas solutions to be applied in maritime industry. In a moment, my colleagues representing particular companies will explain the area of their responsibility within the project. As of today, we have a lot to boast already. The Neptune project is part of the National Recovery Plan. We have also managed to inscribe it as one of the projects into European Clean Hydrogen Alliance, and the project today is one of the elements related to the realization of the European hydrogen strategy and also implementation of local content by developers and investors into offshore wind farms in our country. When preparing this presentation, I wanted to tell you also about what possibilities result from the project, which is a research and development project, but also about its significance for the development of our own local economy. On the one hand, we are talking about entirely new solutions in terms of maritime sector applications. So the vessels have to be fitted in with a full-fledged system for producing energy from hydrogen, distribution of hydrogen. We need to design the systems for the production of hydrogen, not only on the water, but also on the land within the port infrastructure. So we will need suppliers that will deliver energy storage, fuel cells, all sorts of system elements needed. That is why we are laying foundations for the construction of a big business. When we look at the developmental strategy in terms of offshore, let us see what kind of challenges we are facing today. Today, we have installed 23 gigawatts of power in offshore wind farms, but we are to reach, until 2050, 300 gigawatts. On the Baltic itself, there are supposed to be 93 gigawatts of installed power. And this is supposed to happen in 28 years to come. This is quite a challenge. In order to meet the criteria that result from the Green Deal, Poland in 2050 should have 28 gigawatts of power installed in offshore wind farms. If we look at the scale of the project and its market potential, I just enumerate three countries as an example. Baltic states, first Finland. Finland plans to have 10 gigawatts of installed power. As the small Estonia, 1.5 million population, right? They also have ambitious plans of concerning installed powers, 11 gigawatts, and we also, 13 gigawatts. And we have Poland that plans until 2040 to reach the level of 11 gigawatts. Now, if we only took into account those three countries, see what kind of potential we are talking about. I took the liberty to focus on just a fraction of the entire link of chain of value added concerning the vessels servicing wind farms. The Dutch play a key function in terms of servicing offshore wind farms, as they own such servicing vessels. Per 10 turbines, there is one servicing unit, servicing vessel. It is important because on the 30th of September, when we heard about WE's approach, these assumptions were confirmed. So in other words, if nothing changes, then, ladies and gentlemen, we talk about 2040 being the year in which we need 340 new CTV units. We are talking about a gigantic market. We are talking about over $1.5 billion in the budget that will have to be spent for such vessels. What does that mean? That means, ladies and gentlemen, that when you look at the process of constructing such vessels, when you look at what it looks like to prepare the project, to design and to prepare the prototype, then the sheer number of units required means that for 3 shipyards located on the Baltic, we have the full production portfolio for the decade to come, which means that we also need suppliers of components mounted on those vessels. So this kind of projects generate unbelievable opportunities as far as development goes, but we need to meet the standards and realize them first. That is why the steps that we are taking now is the promotion of our project in the countries that have already been mentioned here, so Estonia and Finland, where we try to create new standards for servicing of offshore wind farms based on the units that are powered with hydrogen. And of course, as of today, pretty soon, we are about to sign a big agreement that will finance our project. As I've mentioned to you already, there are 3 companies that implement this project. I would like to ask BPRORAF now to present, because Jakub Roszkiewicz, who was supposed to present in this part, unfortunately cannot be here because he attends a competitive conference to ours, the one in Amsterdam, also on hydrogen. His flight was delayed, so instead I will be the one to tell you about this part of the project that BPRORAF is responsible for, which belongs to the technological group called ASE. The ASE group is the company that was brought up, so to speak, on chemical and refinery sector. It is a company that, as of today, realizes projects mostly in Poland concerning hydrogen production, mostly from natural gas. All those hydrogen nodes that are to be seen in Trzebinia or Gdańsk now are those that result from the activities the ASE group and BPRORAF. These are the projects that I briefly touched upon a moment ago. Very actively, BPRORAF today is investing in technologies that will make it possible to generate green hydrogen. In the Neptune project, BPRORAF is responsible for the coordination of the entire project and for the construction of the entire system for obtaining hydrogen and water and demineralization. demineralizing water, and also building, safeguarding the entire system for the storage. As of today, the project is going to be coordinated by the ASE group, but the most important element, the heart, the core of the entire project is what hydrogen is responsible for. I would like to ask Mateusz now to tell us about the heart of the project, that is about the electrolyzer and the possibility of storing hydrogen. Good afternoon, ladies and gentlemen. Could you please switch to my presentation? Hopefully it will go smoothly. Lovely. Stress level dropped. It is my pleasure to meet you here. Thank you for the invitation to the conference. And of course, I wanted to occupy a few minutes of your time to tell you about our role in the Neptune project. As for what kind of company we are, probably you do not really associate anything with the logotype of our company, which is likely to change soon. SES Hydrogen belongs to Sescom Group that for 12 years has been developing hydrogen technologies within its own activity. The result of those works on hydrogen was creating 4 patents, 2 for alkaline electrolyzers and 2 for steam boilers. One has already been registered, the other one is in the course of being registered. The Sescom Group was also one of the founding fathers of the hydrogen technology clusters. As the company, we've only joined the cluster. In 2021, a decision was made so that all the Sescom Group's activities related to hydrogen go to SES Hydrogen. I'm a managing partner of it, and I'm going to work on commercializing our solutions. Our participation in the Neptune project results from our electrolyzer-related expertise, and as Tamar said, the core, the heart of the project is hydrogen generation, and this is what our company is supposed to do. Within our cooperation, we have a challenge to use the surplus of electricity generated from wind farms on the sea, so that the transformer station can have 1 megawatt installation of electrolyzers to generate hydrogen, out of which will then be bunkered and stored to be used in the servicing vessels for the entire installation. And our part of the project involves creating the entire electrolyzer system, so building it up, constructing it, of course, with ASE in terms of mounting it on the station on the sea with ONC and all the accompanying storage facilities that can be used later on by the vessels. What is the heart of it? Well, the company does not limit itself to building electrolyzers and the system. We have alkaline electrolyzers, but we are working on to other kinds of electrolyzers, also on boilers that I've mentioned. Here, the heart of our project will be modular installation out of many that will together make up for 1 megawatt. It will be fitted for maritime environment. So later on the completion of the project, it can be mounted permanently on the station. This is the scope of the project. I'm displaying it here, but I wouldn't like to burden you now and bore you with the details at the moment. But so we believe that this project, as Tomasz mentioned, is one of the major projects in terms of the development of using hydrogen in maritime installations. We believe that this goal presented by Tomasz and also presented in the Polish hydrogen strategy is attainable, and we would like to be part of it. As for the scope of work awaiting us until the end of 2023 till the end of 2023, this is completing R&D work on the electrolyzer and the entire installation, then its certification, ATEX certification of the electrolyzer, and also maritime certification, which slightly differs for the ones for electrolyzers that are used out of the maritime context. So we hope, as we present here, that until 2023, this work will have been completed and will be possible to join in the celebrations of the installation launch in 2024. Thank you very much. I hope I managed to speak fast enough to gain some time. And now the floor goes to Krzysztof from PCHET, who will show you further components of the project. Thank you very much, Mateusz. Krzysztof, the floor is yours. As I mentioned, Krzysztof is a man for me who introduces me into hydrogen technologies that are used in maritime industry. Krzysztof? Thank you very much. Good afternoon, Krzysztof Czerski, PCHET Engineering. I'm very happy to be here with you, and I'm very happy to have the pleasure of cooperating for so many years with Tomasz, with Nexus. We started with LNG, that now is commonplace. It has become a common fuel for the vessels. The technology that appeared some 10 years ago to be a cosmic one, when you compare it to LNG, is now used. So it is a huge honor to us to have accepted the invitation to participate and be a partner in this project. And it is our pleasure, I hope it will be our pleasure, to design the vessels that will be powered with the hydrogen. A few words on PCHET Engineering. We are a design office that stems from the French market. PCHET Engineering was set up as a design office of PU, not far away from Brest. Actually, there's a collection of shipyards that has grown. There are Nigerian, Algerian shipyards, Singapore, and Vietnamese ones. But for years, our cooperation has been rather informal, and now the majority of our orders was out of the group. So we decided, together with our French partners, to split. So we are now fully private-owned company with a Polish capital, but our main business partner is a PU company that specializes in those small units for servicing wind farms. But not only this, also with different vessels, small vessels, but highly specialized and highly advanced technology-wise. I can see that I have a prompter here. It's so much more comfortable. Now, I myself am responsible for the LNG sector. We create bunkers for LNG, but with my colleagues, we also design a vessel that we are very proud of, that we can say you can see every day. Well, now it's on the sea performing studies for the purposes of wind farms. This is the Oceanograph vessel that PCHET designs. So it's not just designed office, but we also specialize in being mediators, intermediaries for our French partners. So we find them places for shipbuilding in Poland. We are very happy about what Tomasz showed. So 340 potential vessels for servicing wind farms. The potential in Poland is enormous, and we hope that it will be made use of. And these are the three types of vessels that we would like to propose as ideal vessels that could use hydrogen obtained owing to the electrolysis process in maritime so offshore wind farms. The first one, as mentioned by the former speaker, is the one for servicing, so for actually transporting the workers onto the platforms, onto the wind farms. Any turbine, well, 10 such turbines need such a vessel. Every vessel can take on board, depending on configuration, between 12 and 24 service workers. And we believe that the perfect fuel, of course, would be hydrogen obtained in the electrolysis process. And we envisage that the best solution would be placing it in an exchangeable container that could be taken out instead of spending a lot of time on bunkering. But the technology is developing continuously, so we don't claim it to be the final version of this design. All sorts of issues concerning propulsion are down in the bottom part of it, in the floaters. The batteries through direct current power the propellers. And you can see the vessel is to transport service workers. Owing to this platform on the beak, we'll be able to climb the wind turbines. The location of the wind turbines speaks for going for small service vessels from Ustka and Łeba, reaching for the places where the turbines will be placed. The distance is not big. We believe that such a vessel of 20 knots will during one day be able to transport the service workers sufficiently. Of course, we can also propose a bigger one, a base, from which the smaller ones would take the service workers and transport them further on. But the big portion in the budget of the companies dealing with servicing of the platforms is the wages for the employees. So when we place them on board a ship and for 2 weeks they live on the sea, then the wages, of course, will have to be higher. So we believe it's better for them to stay at home and be be transported by those small vessels, taking them from Łeba or Ustka. Another vessel that we would like to offer to be used, and again powered with the green hydrogen, is an eco water tram that can take around 100 passengers. Here we would like to propose the pressure tanks with hydrogen to be placed on top of the vessel. And owing to our liking to the bicycles that I share with Tomasz, we would like to have a parking for bicycles to be placed in the rear part of the vessel, rather than the tank with hydrogen. There are different configurations that we offer. It could cover the entire network of waterways around Gdańsk. This is a map that looks somewhat archaic, but it has been downloaded only recently from the official website of the Inland Waterways Office, and it shows already the installation in the Vistula spit that has been dug up. So I would like to use it to shift to another design, also hydrogen-powered, that is to the passenger ferry that could transport around 500 passengers and 80 cars, that could take the burden of the road network by transporting tourists during holiday season from Elbląg to Hel via the Vistula spit. Now the speed is around 20 knots, so not so this how much time we need going on our car through the dry city and Władysławowo, provided there are no traffic jams. When there are traffic jams, of course, it is beneficial to use the ferry. At night, it could transport cars that would deliver goods to all sorts of shops operational in the Hel Peninsula. There are 20 connections for charging electric cars as well, so these cars could also be electric.
So, thanks to hydrogen, we could have a shortcut, which would be zero emissions, and which would definitely bring life to the port of Elbląg. Thank you very much for your attention. I've tried to present as quickly as possible to save time. Thank you very much. We are showing that hydrogen can be viewed from various perspectives, from the point of view of building new business models or systems. Marek? I'd like to remind you there is an opportunity to ask questions at this conference. I've received a question right now, so we'll try to find an answer. The question is the mentioned 28 gigawatts, 28 gigawatts of the installed wind power plant. How many turbines is that? We're going to calculate that, and we're going to answer that in a second. But at this point, I'd like to ask another speaker.
Hydrogen Association, Mr. Ain Laidola. Mr. Laidola, the floor is yours, and you can to tell how really the small country as Estonia has so big ambitions planned for renewable energy.
Right. Good afternoon from Estonia. Yes, let's talk about the latest hydrogen developments in my home country, with population only just over 1 million, 1.3 million people here living in Estonia. Please accept not giving you a chemistry lecture, just giving a simple country report. and giving you appetite to bring your hydrogen technology and catch wind over here. So let me share my screen and right. Here it is. Right. So to start describing our energy system, so where we are coming from, we're just exiting the Stone Age in Estonia. We have produced electricity from oil shale years, and we lost our electricity independence in 2018. Today, we import half of our electricity consumed. But the future looks bright. We are entering into clean energy age, and most probably the first offshore wind parks we are witnessing 2030 plus. And I show you a rock. This is a rock we are used to burn in our power stations. And this rock is not coal. Technically, we are coal-free country. But in fact, oil shale is very, very much CO2 intensive fuel. Right, let's have a look where we are now with our electricity and energy consumption. You see, we are consuming, say, 10 terawatt hours of electricity, 10 terawatt hours of heat, and also we consume 10 terawatt hours of liquid fuels. We have two main suppliers in Estonia. The fuel is coming mostly from Finland, from Neste, and another big supplier is Orlen. So you can see, normally we are talking, if we talk energy, we talk 4 sectors. The missing slice in the cake is industry. We don't have energy-intensive industry in Estonia, but things can change. The precondition for industry is availability of hydrogen, and that might happen in 10 years' time. So, climate neutral Estonia. So in EU, the trigger for hydrogen economy, we see this is climate targets. So let's have a look what sectors have to be decarbonized in Estonia. We talk power, 10 terawatt hours, electricity consumed, 50% imported today. If we talk heat, well, mostly heat is covered by local biomass. The peak load is covered with natural gas, and also some domestic consumers are using natural gas. In transport sector, we, on top of liquid transport fuels, we are talking about maritime fuels have to be decarbonized, also aviation. Only one ferry company in Estonia, only one company, Tallink, is consuming 2.4 terawatt hours of liquid fossil fuel today. That have to be changed. Gas infrastructure, 4 terawatt hours. The big numbers, something different should be flowing in our gas grid 2050. So what sort of resources we got in Estonia? We have a wind. As Thomas mentioned before, we have evaluated how much wind resources or how much offshore wind parks we can install. Local companies have came up with the new ideas, new development plans. The wind parks and wind turbines are getting bigger. Now we are counting, but we have a wind development plan, 76 terawatt hours. We have a solar. Of course, we have a sunshine during the summertime, but we are living on 59th of latitude. So we have to think about the storage. We never had a storage issue before. We always had fossil fuels available all year round, but nowadays we need to talk about storage if we want to employ more solar and for more wind. Of course, we have a biomass as well. Estonia has 50% of the land area is covered with forests. This gives us about 12 terawatt hours of energy. What happens with biomass? We have a local consumption, but also we are exporting 1 million tons of wood pellets every year. So we are questioning now ourselves, this is green carbon, what we are exporting. Can we do something better with our green carbon? Maybe just to use it to produce some chemicals or some gas or some liquid fuels, some gasification processes, or but all these ideas, they require hydrogen, which we hope to see very soon. So what you can see on that photo, you can see on that photo that you can't see any offshore wind parks over there. Yes, of course, they are under development though now. 22 gigawatts have proposed by Estonian developers. And if we take the capacity factor, 40%, this works out something like 76 terawatt hours of electricity produced every year. As I mentioned before, our local consumption is 10 terawatt hours. Even if we employ more heat pumps and we bring battery electric vehicles on the road, we still have overproduction. So what sort of tools and what sort of infrastructure we require? Of course, we need pipeline for hydrogen. How we can get rid of a product? If we start producing hydrogen on sea, we need something to carry away our product. Is that product going to be electricity in form of electrons, or is that going to be hydrogen in molecules? We need infrastructure which is not existing today. And let's define what is hydrogen. I'm saying that hydrogen is upgraded electricity. Hydrogen is made from water and from electricity. So, of course, we would like to see where is the business. The storage is another issue. If we are linked with a hydrogen pipe, we are asking ourselves, can we use the hydrogen produced during the summertime? Can we use that over the winter period? We don't have geological formations like a salt caverns. Let's do business with Polish people. You have a salt caverns. Let's agree to store some hydrogen for us. So what else we need? We need electrolyzers. We need the systems to clean up the water. And we need a hydrogen hub. We need a port, which will be the home depot for offshore wind park service vessels. So I mentioned the natural gas, 4 terawatt hours. We have no idea at the moment how we can make it different than fossil one. But we have to think about that. Is that going to be hydrogen flowing in this tube? Or we are talking biomethane. These biomethane resources are also limited. We don't have a gas storage in Estonia. We don't have LNG terminal either in Estonia. Do we have a plan, you may ask? Of course we have. This is rather than plan, it's vision. It's hydrogen backbone vision. Estonian TSO Elering is a part of that plan. And if you look on a map, you see there is a plan or idea or vision to bring or to build hydrogen network from Bothnia Bay, which is between Finland and Sweden, down to Central Europe to carry hydrogen. And we are planning to be part of that business. So this is another vision. So it's we can't do that alone. We have to work together in this region. You see, Sweden, Finns, they can produce offshore wind, produce hydrogen, and send it where the market is, where the demand is. We believe the demand is in Central Europe. And it looks silly if we are not joining this project, if the tube is bypassing Estonia, and we just need to get a little share in that tube, which is helping us to get rid of our product. So, as I said, storage. What is a storage? If we talk day and night storage or short-term storage, battery works fine. Also works fine. The pump hydro storage plant, which is planned in Estonia as well. But this is workable only for 12 hours. 12 hours is not enough. Sometimes we have no wind during 2 weeks in Estonia. So that means we need something different. And this is helpful. The hydrogen backbone connected to Central Europe with a salt cavern, that might be a solution. Let's find it out. So hydrogen hub. In northwest, we have a port called Paldiski, which is a perfect location for us. There is a gas pipeline, which is connecting Estonia and Finland, 3,400 megawatt. There is an electricity interconnection. There is a railway connection to east, south, main road crossing there. And the most important thing is there is industry-friendly local community, which is welcoming all new investments. So, to sum up, what's up in Estonia now? What we are doing here, we are writing a document which is called Estonian Hydrogen Roadmap, and that should be ready end of this year. So we make a plan. So we have some investment coming from state, which is from the recovery fund, 50 million euros for hydrogen development. Upcoming study with duration of 15 months, gas decarbonization study. We do that together with our neighbors, with Finland, with Lithuania, with Latvia. And the most important document we are hoping to see early 2022 is Estonian Maritime Spatial Plan. This gives us answers. How much sea area is available for offshore wind production? And of course, very exciting is that Estonia, small Estonia, proposed IPCEI, hydrogen IPCEI projects worth 1 billion euros. Thank you. That's it.
Thank you, Iona. I just want to confirm that we have started already cooperation. We cooperate as the Estonian Hydrogen Association and our Pomeranian cluster, hydrogen cluster, and some of our company already cooperate. And you also mentioned potential cooperation about salt caverns, and that's why I like. Personally, I like very much your new word, and probably I will promote it further. Hydrogen is the upgraded electricity.
It is, yes. It's first stage upgrading is electricity to hydrogen. But I did mention also we have a green carbon available. So if the first stage is done, we have a hydrogen available. And next step is, if we do like, we can have a further value-added product available, which is we put two friends together, which is green carbon and green hydrogen, to make some liquid or gaseous fuels. Let's do it.
Thank you very much, Ein. Chciałbym tylko Państwu powiedzieć jedną rzecz.
I'd like to mention one thing to you. Estonia today has a national recovery plan, so they're very happy. They've approved this plan, so the plans that we've just heard about will be able to be carried out. So answering a question from the last part, these turbines will require 1,800, there will be 1,888 each of 15 megawatts. So at this point, I'd like to ask our next speaker, who will tell us about certain guidelines which every company should prepare for in accordance with the decarbonization program, especially the newest program, Fit for 55. Pretty much each and every enterprise will have to calculate and present its carbon trail. I'd like to invite Marcin Cholewa to present. The floor is yours.
Dzień dobry Państwu.
Good afternoon. Thank you very much for introducing me. Let me just turn my presentation on. Unfortunately, today I've had some technical issues with my camera. Fortunately, we'll be able to hear each other well, though. I hope you can see the screen.
Tak, wszystko dobrze.
Great. So we know very well the level of CO2 emissions is constantly increasing. Global CO2 emissions coming from fossil fuels in 2018 were nearly 38 billion tons. On the graph, you can see which regions, which countries are responsible to the greatest degree for CO2 emissions. 80% of global emissions responsible for them are 20 countries such as China, USA, India, Russia, Japan, and on that list of these 20 countries we have Poland as well on the 20th place. Despite the fact that in Europe we see a drop in CO2 emissions globally, we can observe a significant increase. If we were to compare emissions from 2018 and 2019, we could see an increase of nearly 1% of global CO2 emissions. This means that each and every one of us, each inhabitant of our planet, generates emissions in the amount of nearly 5 tons of CO2 annually. Of course, in Europe, Europeans generate a bit more. This is about 6.5 tons CO2 annually. The growing quantities of emissions and changes require active steps to handle their negative consequences and not to result in climate catastrophe on the planet. At the end of 1980s, it was pointed out that climatic changes need to be stopped. Since that time, we've met and we've taken on many steps aimed at fighting global warming. In 2015 in Paris, our leaders entered into an agreement in which, or based on which, our efforts aimed at decreasing the temperature rise to the maximum of 1.5 degrees Celsius were put in writing. That means obviously limiting until 2050 emissions of greenhouse emissions to levels which will allow them to be absorbed by the ecosystems or by introduction of such technological solutions which will aid in reaching that goal. And many of us see hydrogen as key in reaching that goal. One of the tools which helps us to estimate our impact on the environment is the carbon trail, about which I would like to tell you a few words about. I'd like to start by presenting a short movie which will tell us a little bit about the subject. The movie will be in English. If the audio is not clear, I'll try to do something about it.
Carbon footprint. But what is that exactly? Just like an actual footprint, it's a mark you leave upon the environment. No, not with your shoes, but with every action that releases carbons. Those are the harmful gases, such as CO2, which are pumped out by burning fossil fuels like oil and gas. The more fuel you use, the bigger your footprint will be. You may think that by driving your car, the only carbons you release come from the engine, but no. Consider the carbons that are emitted just to get fuel into the tank. From the energy needed to extract the oil from underground, the pollution caused by transportation and refinement, to the final delivery to your local petrol station. Not to mention the CO2 released by manufacturing your car in the first place. More than you thought, huh? So unless you live in a cave, you and everything you own has its own carbon footprint. Read a book, printing and distributing. It uses energy. Brush your teeth, and your utensils will have a history in a factory. Even something as basic as an apple could have traveled hundreds or even thousands of polluting miles to end up in your local supermarket. You see, it's pretty much impossible to leave no carbon footprint behind, but that's no reason to stop trying. Think about your actions and choices, and you'll be able to reduce your personal mark after all. That's how you really put the boot into climate change.
Czyli czym tak naprawdę jest ślad
So, what is actually carbon trace? We might say that it's the sum of emissions of greenhouse gases, which are created during the cycle life of a given product or service. It can also be calculated for any event, organization, city, county, or even a country or an individual. This indicator is a tool to coordinate various decisions and measures. It also allows us to diagnose main pathways of greenhouse gas emissions and taking steps aimed at eliminating them. The carbon trail, I'm sorry, certain technical problem here. But going back, the carbon trail is expressed as the equivalent of CO2, which is a universal unit pointing to the increase of each of the greenhouse gases. You probably still have in mind the movie we've just seen. The movie presented the life cycle of a car trip. So in calculating carbon trail, it's important to take into account both direct emissions, which is taken into account when using the vehicle directly, and also other emissions which stem from the entire life cycle of the product, which should be taken into account when calculating the carbon trail. In order to obtain cohesive framework for calculations, the calculations of carbon trail were standardized, the most popular standard, and also the one dealing with GHG management emissions is the GHG standard protocol and the ISO 14064 norm. Regardless of the method we choose, it's necessary to carry out an in-depth examinations of key positions in organizations, which should or can be significant sources of influencing the environment, burdening the environment. A few words about GHG protocol, the greenhouse gas protocol. It has 3 ranges of emissions within which we have all emissions produced by our enterprise, especially those directly emitted by us, as well as those from the outside organizations. The first range, which is marked in green, these are the direct emissions which are created as burning fuels in stationary or mobile points belonging to the company, or which are supervised by the enterprise. These emissions come from, among others, from burning fuels in our own boiler rooms, generators, cars, as well as the leakage of freezing agents. So if we were to burn hydrogen, the emissions would be shown here in this scope, but due to the fact that during burning of hydrogen only water is created, then the emissions would be at the 0 level within that scope. Now, scope number 2 includes all the indirect emissions connected with burning of consumption of purchased energy, steam, even also cool air. And the third scope deals with all other remaining emissions, indirect emissions remaining outside of the control of organizations. They are divided into a number of categories. For example, business trips, commuting, use of resources, goods, and so on and so forth. So here we could see emissions dealing with the production of hydrogen we are actually burning. When we're going to carry out an inventory of these data in accordance with the presented data, we are calculating emissions of the carbon trail for each of the position using the so-called emission indicators. In this way, we receive results which can be presented in division presented previously and the scopes presented previously, as well as the value for the entire organizations. Final calculations of the carbon trail should also be given in recalculation to so-called functional unit, which should reflect the profile of a given company and might constitute a reference point for comparing the results with competition or for future changes in the company when it comes to CO2 reductions. Such functional units may be, for example, for courier services, this could be the amount of emissions per carried package or 1 kilogram of package, or emissions per specific product. For example, 1 liter bottle of water or Coca-Cola. When it comes to services, this can be the number of serviced customers, that is emissions connected with servicing a single customer. Some manufacturers already on their products give information regarding CO2 connected with producing a given product. Personally, I saw on Coca-Cola bottles information regarding the fact that production of the bottle is connected with generation of such and such amount of CO2. But why should we calculate the carbon trial at all? Well, the biggest advantage of doing that is simply consciousness of the fact that is gaining knowledge, that is knowing the emissions that our organizations or product generates. Another advantage is possibility of comparing our emissions with competition, which may also have a motivating factor. Well carried out calculations allows us to diagnose at which level of production most emissions are generated, which in the future will allow us to take mediation measures. Optimization can be very simple. For example, it can be getting rid of empty rounds in transport or implementation of electronic document flow. Transparency. By transparency, we understand that the possibility of being a transparent, well-trusted company, also competitive in comparison to others, in comparison to those companies which did not calculate the carbon trial hours by reporting to CBP. Another advantage can be possibility of developing certain plan strategies based on which we can attempt to decrease the emissions generated by our company or product. Another point is meeting the expectations of demanding customers who are concerned about the environment. Eco-signage, it's also possibility of using independent eco-signage on our products, which will allow us to demonstrate that we are a responsible and eco-friendly company. Increasing number of customers require from companies to present their carbon trial calculations in addition to hope when it comes to scope 3, calculating on emissions. The customers also want to see their impact on the environment in order to make a decision with whom to cooperate with. And of course, costs. Ecological measures are very often very costly. Nevertheless, as a result, they allow us to lower operational costs connected with, for example, purchase of resources, energy, electrical or heat energy, or decrease environmental fees. When we talk about carbon trial, it's also we might also talk about hydrogen, the topic of our today's meeting. Hydrogen is basically zero, means basically zero emissions at the point of its burning, that is in the so-called direct emissions. This is due to the fact that only water vapor is created, its burning. However, the advantage of hydrogen can be fully seen when we take into account its full life cycle. That is what we've talked about before, that is taking into account the emissions connected with its production or its transport. Some hydrogen production technologies, such as electrolysis, in case of using electricity coming from sustainable renewable energy sources, mean basically zero emissions. However, when electric energy coming from other sources is used, emissions from hydrogen production can be quite high. And this, regardless of the origin of hydrogen, it can find wide use in, for example, in urban transport, when the end-of-pipe emissions will not pollute urban environment. and they will be shifted outside of city centers in contrast to fossil fuels.
Szanowni Państwo,
Ladies and gentlemen,
transformacja w kierunku
transformation towards low emissions economy is a necessity stemming mostly from a feeling of responsibility for our environment.
naszych działania
Our measures, our economic success and climate protection must go hand in hand, and here we can be helped with calculations of carbon trail. So, summing up, in conclusion, I'd like to encourage you to estimate your impact on the environment by calculating your carbon trail. This can be the basis for looking for new ecological solutions with the good of ourselves and our planet in mind. Perhaps for some of us, hydrogen will be the answer, which is both ecologically and economically justified.
Ja ze swojej strony
Thank you very much.
dziękuję Państwu bardzo za uwagę.
Thank you for your attention. I encourage you to contact me. Marcin, thank you very much. I'd like to tell you more a little bit about more of the practical aspects that Marcin has mentioned. We are contacted by companies which receive questions from foreign clients who require from Poland services and goods and the maps of carbon trail reduction. In our opinion, such queries, such activity result in the reshuffling of the added value among suppliers, and those companies which won't be able to prepare this type of maps, these types of reports, information, will have problems in selling their products. I'm a witness of that. One of such queries was directed to one of the bigger milk producers in Poland, and part of milk was returned because specific documentation connected with CO2 emissions and carbon trail was not provided. Therefore, it's a great challenge. We'll obviously have to work on it very hard because we're going to need green energy in large amount and green heat as well. So we are convinced that hydrogen gives just that. And not just a bottle of Coca-Cola that was mentioned by Marcin, but also on the boxes, for example, on Vasa bread, you can see their carbon trail and how they are aiming to decrease CO2 emissions. Ladies and gentlemen, we're ending the end of our sessions. I'd like to thank all those who have presented.